Hello and welcome to Mr. Tompkins Ed Tech. This series of videos provides work solutions for the GCSE Maths Topic Test produced by AQA. This video is Surds. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. Okay, question 1a. Simplify root 15 all raised to the power of 4. Now if I take root 15 and rewrite it in index form, what I'm going to get is 15 to the power of a half, then raised to the power of 4. So I've actually got an index of an index, which means I can multiply these two indices together. So 15 to the power half raised to the power of 4 is the same thing as 15 to the power of a half times 4. In other words, 15 to the power 2. So that's my simplified answer, 15 to the power 2. Question 1b. Simplify root 96 divided by root 8. Give your answer in the form of a root 3, where a is an integer. Okay, so I've got root 96 divided by root 8. Now I can put that as 1 third and put it as a fraction, 96 over 8, can't I? I can rewrite it as 1 third like that. And 8 goes into 96 how many times? I think it goes in 12 times, doesn't it? So that's the same thing as root 12. And root 12 is the same thing as the square root of 4 times 3, which is the same thing as root 4 times root 3, which is the same thing as 2 root 3. So that's how it simplifies, 2 root 3. Question 1c. Simplify the square root of 18 times the square root of 50. Now I could put those under one square root and work out what 18 times 50 was and then look to simplify, but actually it might be easier to simplify them first and then combine what's left. Root 18 I can already spot has a square factor, so I can rewrite 18 as 9 times 2, and again 50 has a square factor, so I can rewrite 50 as 25 times 2. That allows me to square root both of those parts separately. So the square root of 9, that becomes the square root of 9 times the square root of 2 times the square root of 25 times the square root of 22. And I know what root 9 is. It's 3. So that gives me 3 root 2. And I know what root 25 is. That's 5. So that gives me 5 root 2. So I've got 3 root 2 times 5 root 2. I know that 3 times 5 is 15, and I know that root 2 times root 2 gives me 2, so then the final answer is 30. Okay, question 2. Circle the value that is equivalent to root 20 plus root 45. Now again, I can rewrite root 20 as the square root of 4 times 5. Note that 4 is a square number. And I can rewrite 45 as 9 times 5. So the square root of 4 is 2, so root 4 times 5 becomes 2 root 5. And the square root of 9 is 3, so root 9 times 5 becomes 3 root 5. And then I'm adding these two together. Now you can add surds together just the same way you can algebraic terms. So if I've got 2 of something and I add on 3 of that same something, then I've got 5 of those things. So that's the same thing as 5 root 5. So circling my answer, it's that one there. Question 3, circle the value that is equivalent to 6 root 15 divided by 3 root 5. Now, I think it'd be clear if I rewrite this as a quotient, so 6 root 15 over 3 root 5. Then I can divide the 3 into the 6, giving me 2. And I can divide I can put those surds under one surd, can't I? So that's the same as the square root of 15 over 5, and 15 divided by 5 is 3. So it's equivalent to cancelling that 5 into that 15 and giving me 3. So that cancels down to 6 divided by 3, 2. Root 15 divided by root 5 is root 3. So 2 root 3 is the answer. It's that one there. Question 4. Show that root 3 plus root 27 all squared can be written as an integer. Well, when you square a bracket like that, it's the same thing as multiplying it by itself. So root 3 times root 27 like that. So either I can do claw method or FOIL method or smiley face method, or I can just know what the identity is and expand it that way. Either way, I'm going to get root 3 times root 3, which is 3. I'm going to get root 3 times root 27, which is, well, 3 27s are 81, aren't they? So that's plus the square root of 81. And I've got root 27 times 3, which is another root 81. And I've got root 27 times root 27, which is 27. Okay, so I've got 3 plus 27, that gives me 30. And I've got the square root of 81, which is 9, and another square root of 81, which is another 9. So altogether, 30 plus 9 plus 9, 39, 48. So the answer is 48. So it can be written as an integer. Question 5. Rationalise the denominator and simplify. So if I've got 24 over root 6, now the way to rationalise a denominator is to take this surd denominator and then multiply your number through by that same value divided by that same value. So you'll see that that's also root 6 over root 6. So I just take that denominator and I multiply top and bottom through by it. Now root 6 divided by root 6 is 1. So multiplying through by 1 is not going to change my value, but it will change its form. So if I've got root 6 times root 6 on the denominator, that is going to give me 6. And on the top I've got 24 root 6. Now I can now divide that 6 into the 24. 6 goes into 24 4 times. So my final answer is going to be 4 root 6. Question 6. Here are the first 4 terms in a geometric progression. Now, a geometric progression is a sequence of terms where each successive term is a multiple of the previous one. So, and we can work out a common multiplier by dividing 2 consecutive terms together. You can see if I take root r and I want r, I need to multiply it by root r. So root r times root r is going to give me r, and then r times root r is going to give me r root r, and root r times root r is going to give me r squared. So we need to work out the 10th term. So that's our first, second, third, fourth. So we need to do this again. 5th, 6th, 7th, 8th, 9th, 10th. We're going to have to multiply through by root r 6 more times, aren't we? So root r to the power of 6 times r squared. So I've got r squared already. So if I'm going to then multiply it by another 6 lots of root r. Now root r times a raised to the power 6. The square root of a number is the same as that number raised to the power of a half, isn't it? So that's like root half to the power of 6, and I've got an index of an index. Half times 6 is 3, so that gives me r squared times r to the power of 3. So then I've got two numbers with the same base, so I simply need to add their indices together. R squared times r to the 3 is going to give me r to the power of 5. Question 6b. When r is equal to 8, work out the sum of the first 4 terms. Give your answer in the form of a lots of b plus root 2, where a and b are integers. Okay, so if r is 8, then my first 4 terms are going to be root 8 plus 8 plus 8 times root 8 times 8 squared, then, isn't it? So just subbing that in, so I'm going to get my first term is root 8, then I'm going to get an 8, and then I'm going to get an 8 root 8, and then I'm going to get 8 squared. Okay. So root 8 I can express as, well, let's just add those together first, because let's collect like terms. I've got root 8 and 8 root 8, which together gives me 9 root 8, and I've got 8 and 8 squared. 8 squared is 64, plus my other 8 is going to give me 72. So I've got 72 plus 9 root 8. Okay, but root 8 is the same thing as, so I can rewrite that as 72 plus 9 lots of 4 times 2. And the reason I would do that is because I can square root 4 to get 2. Combining that with the 9, that's going to give me 72 plus 18 root 2. It's not quite in this form yet, is it? I need to then factorize it to make it look like this. So I need to take out a common factor. Now it would be handy if 18 would go into 72. Does it? If I take 18 out, then how many times does 18 go into 72? It goes in 4 times, isn't it? 18, 36, 72. Yeah, it goes in 4 times. 4 plus root 2. So that does look like it's in the right form. So a is equal to 18 and b is 4, and the rest is all fine. So all done. Question 7. All lengths are in centimetres. Work out the area of this rectangle. Give your answer in the form of a plus b root 2, where a and b are integers. Okay, well, we're going to work out the area. Now, the area of a rectangle is length times width, isn't it? And for this example, this is the length and this is the width. So I'm going to multiply those two expressions together. So I'm going to get 3 plus root 2 times 1 plus 2 root 2. We're going to have to use claw or foil or smiley face or whatever to multiply these out. So if I do that, then I'm going to get first two terms multiplied together. 3 times 1 is 3. Outside terms multiplied together. 3 times 2 root 2 is 6 root 2. Inside terms multiplied together. Root 2 times 1 is root 2. And last terms multiplied together. Root 2 times 2 root 2. The root 2 times the root 2 gives you 2, and multiplied by the 2 gives you 4. So I get that. 3 plus 6 root 2 plus root 2 plus 4. So you'll notice I've got two types of terms here. I've got numbery terms, 3 and 4, and I've got terms in root 2. So let's combine those together. So 3 plus 4 is 7, and 6 root 2 plus root 2 is 7 root 2. So done then, isn't it? It's in the form of a plus b root 2. A is 7, b is 7. All done. Question 8. For a right angled triangle with sides a, b and c, Pythagoras' theorem states that a squared plus b squared equals c squared. Is this triangle right angled? All lengths are in centimetres. Okay, so if it is a right angled triangle, if this is a right angle, then Pythagoras' theorem is going to have to hold, then, isn't it? That a squared plus b squared is equal to c squared. So if we work out a squared plus b squared. That's a then, and that's b. Let's work out what a squared plus b squared is and see if it is actually equal to c squared. Okay, that's my plan anyway. So let's take a squared. A squared equals, well, it's going to be 3 plus root 3 all squared, isn't it? Which is the same thing as 3 plus root 3 times 3 plus root 3. So doing FOIL on that then, or claw or smiley face. What do I get? I get first terms, 3 times 3, which is 9, outside 3 times root 3, which is 3 root 3, inside root 3 times 3, which is 3 root 3, last root 3 times root 3, which is equal to 3. So I've got two types of terms. I've got numbers and I've got terms in root 3. So let's add these up then. So 9 plus 3 is 12, and 3 root 3 plus 3 root 3 is 6 root 3. So a squared gives me 6 root 3. I'm going to do the same thing with b. So let's take b and square it. b is 2 plus root 12. So if I square it, I'm going to be multiplying it by itself. So 2 plus root 12. And again, FOIL brackets. So that gives me 2 times 2, which is 4. 2 times root 12 is 2 root 12. Root 12 times 2 is another 2 root 12. And root 12 times root 12 is 12. So again, I've got two types of things here. I've got numbery terms and I've got terms in root 12, which I can add together. So 4 plus 12 gives me 16, and 2 root 12 plus 2 root 12 is 4 root 12. Before we move on though, I'm just going to see if I can simplify that surd part, because I've noticed 12 I can rewrite as 4 times 3, where 4 is a square number. So if I do that, so I take my 4 and rewrite it as 4 times 3, I can actually simplify this surd down a little bit, can't I? Square root of 4 is 2, combining that with the other 4 is going to give me 8, so that's actually 16 plus 8 root 3. Okay, so now I can add a squared and b squared together and see what I've got in total. So what is a squared plus b squared? It's going to give me, it's going to be my expression up here plus my other expression here. So I'm going to get 12 plus 6 root 3 plus 16 plus 8 root 3. So again, I've got two types of things. I've got numbers and I've got terms in root 3, which I can add together. So 12 plus 16 is 28, and 6 root 3 plus 8 root 3 is 14 root 3. So a squared plus b squared is 28 plus 14 root 3. Now, phew, that was quite a lot of work, but we're not quite done yet, because we also need to know what c squared is. So let's just draw a line there and come back up to the top and see what c squared is equal to. C squared is going to be my hypotenuse all squared. So 5 plus root 3 times another 5 plus root 3. Okay, so again, lots of multiplying out double brackets involving surds here. Should get lots of practice of this. So 5 times 5 is 25. 5 times root 3 is 5 root 3. Root 3 times 5 is another 5 root 3. And root 3 times root 3 is 3. So again, numbery bits, surdy bits that we can add together. So 25 and 3 is 28, and 5 root 3 plus 5 root 3 is 10 root 3. Okay, so we're in a position now that we can compare these. So I had a squared plus b squared, and I found that that was equal to 28 plus 14 root 3. Now, is that the same thing as c squared up there? No, it's not the same, is it? Because I've got 20, the number parts are the same, they're 28, but the surd parts aren't the same. I've got 14 root 3 for a squared plus b squared, and I've only got 10 root 3 in the other one. So these two things are not equal to each other, and therefore the triangle cannot be right angled. Okay, so quite long that question, but really it's just one skill repeated over and over again. It's how to square a bracket where you've got surds in it. And if you manage to work your way through all the way through that question, you've got lots of practice of doing it. Okay, job done. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.